Hello everyone, and welcome to today's video tutorial. In this video, we are going to learn how to derive Newton's equations for uniformly accelerated motion. These equations are very important when we want to describe the motion of a body on a straight line. So let's consider a body which starts its motion with an initial velocity u and moves with a uniform or constant acceleration a, covers a distance s within a time period of t, after which it attains a final velocity v. It is essential that we remember the body moves with a uniform acceleration. For a body moving with a uniform acceleration, the acceleration a is the change in its velocity per unit time. That is, acceleration a is equal to change in velocity divided by time. When you want to write this in symbols, it will be a is equal to v minus u divided by t. So acceleration is basically change in the velocity of a body within a period of time. Usually, when a body is accelerating, its final velocity is greater than its initial velocity. That is why the change is the final velocity minus the initial velocity. Now let's make v, that is the final velocity, the subject of this equation. We are going to get v is equal to u plus at. And this is the first equation of motion for uniformly accelerated bodies. And it basically comes from the definition for uniformly accelerated motion. Since the body had two velocities, that is the initial and the final velocities, we can find the average velocity of the body. To find the average velocity, we are supposed to add the initial velocity to the final velocity and divide by 2. So mathematically, average velocity v bar is equal to u plus v over 2. Let's call this equation A. Also, average velocity can be expressed as total displacement s divided by the total time taken t. So mathematically, average velocity v bar is equal to s over t. Let's call this equation B. Now when we look at equation A and equation B, we see that they are the same because both of them are expressing the average velocity of the body. And so we can say that equation A is equal to equation B. Equating these two expressions will give us u plus v divided by 2 is equal to s divided by t. At this time, let us make s the subject of the equation. We are going to get s is equal to u plus v divided by 2, all multiplied by t. Let's call this equation 2 as the second equation of motion for uniformly accelerated motion proposed by Sir Isaac Newton. That is the source from which we are going to derive the other equations of motions. If you want to proceed to find the rest of the equations, what we have to do is that from equation 1, we can substitute the expression for v, which is u plus at, into equation 2. When we do that, we are going to have s is equal to u plus at all divided by 2 all multiplied by t. Then s is going to give us 2u plus at divided by 2 all multiplied by t. Then expanding the bracket will give us 2ut plus at squared all divided by 2. Mathematically, we can divide this single fraction 2ut plus at squared divided by 2 into two fractions. That is, s is going to give us 2ut divided by 2 plus at squared divided by 2. And so by simplifying this, we are going to get s is equal to ut plus half at squared. And this is the next equation of motion. So let's call it equation 3. We are left with the last equation of motion to derive. And to do that, we go back to equation 1 and make t the subject and substitute the expression for t in equation 1 into equation 2. So making t the subject in equation 1, we are going to get t is equal to v minus u over a. So substituting this expression into equation 2 gives us s is equal to u plus v over 2 all multiplied by v minus u over a. Now we are going to get s is equal to, into brackets, u plus v multiplied by v minus u all divided by 2a. We have to observe immediately that the numerator is difference of two squares, and if we simplify it by removing the brackets, we are going to get v squared minus u squared. And so the expression is going to give us s is equal to v squared minus u squared divided by 2a. And by rearranging, we are going to get 2as is equal to v squared minus u squared. Some people want to make the v squared the subject, and that will give us v squared is equal to u squared plus 2as. And so these are the equations of motion for uniformly accelerated bodies proposed by Sir Isaac Newton. In summary, the equations are: 1. V is equal to u plus at. 2. V squared is equal to u squared plus 2as. 3. S is equal to ut plus half at squared. And the fourth one, s is equal to, into brackets, u plus v divided by 2 all multiplied by t.